Alright, this video is going to be an explanation of how we can use synthetic division and long division, really, if you'd prefer to do it that way, in order to actually help ourselves factor polynomials. Sometimes factoring doesn't work with some of the special methods that we've learned. But if we want to just factor out one term or one piece, synthetic division or long division is a great way to do that. Now, the remainder theorem is something that we've actually learned before. We called it synthetic substitution. And what it says is if you divide a top polynomial here, so 1x cubed, 2x squared, minus 6x, and a negative 9, by x minus 2. And remember, we're going to put the 0 of the bottom here, or we're going to put positive 2, since that's what would make x minus 2 into 0. Right? X minus 2 equals 0, so x equals 2. That's what we're going to put in the box. If we went ahead and divided those two things, so drop down the 1, multiply by 2, don't forget to add, multiply again by 2, add them up again, and multiply again by 2, we end up with this negative 5. Now, if we were just doing synthetic division, we would take and call that x to the second plus 4x plus 2, and we would add on this negative 5 as a remainder divided by x minus 2. However, the remainder theorem says that if we end up with negative 5, that remainder, that r, is actually equal to what f of 2 would have been equal to. And again, that's essentially what synthetic substitution said. So that's all the remainder theorem does. However, there is a special fact that if that remainder can come out to 0, then we've actually found a factor of our polynomial. So if we go ahead and synthetically divide this problem, you'll quickly notice, and be careful, no x cubed, so fill in your 0, but you'll quickly notice that we're going to get a remainder of 0. We'll drop down our 1, make negative 4. Negative 4 is positive 16. Adding up here and working our way across, we get a remainder of a 0. That makes x plus 4 a factor of our polynomial on the top. So when we write out our answer, we could even go as far as to say if this was f of x divided by x plus 4, right here, then f of x equal to x to the 4th minus 16x squared plus x plus 4 could have been written as the factor x plus 4 times, again, if this was x to the 4th, this becomes x cubed. So we're going to have x cubed minus 4x squared plus 0x's plus 1. And we've actually just factored one factor or one term essentially out of our polynomial. Our x plus 4 factors perfectly out of there. Now what that can help us with is when we're looking at a polynomial, if we want to find all the zeros of that polynomial, well, remember, if the remainder theorem says that if it factors out, it'll give you a 0, right? Or we go back here real quick. If our remainder were 0, essentially we would find a number that we plug in that gives us 0. It finds us x-intercepts. So to find the zeros of a function, right? To find the zeros of a function of a polynomial, we just need to be able to plug in a number that gives us 0. Well, if we go ahead and plug in 4 into our polynomial, we can do some synthetic division. Given that it's supposed to be a 0, that k equal to 4 should come out perfectly to 0. Again, just drop in the 1, multiply and add, multiply and add, multiply and add, and we get that perfect 0. That means 4 is a 0 of my function. What it also means is I got x squared minus 4x minus 12 as my remainder, essentially, as my leftover stuff, my other factor. And I can set that equal to 0 to find my remaining zeros, which we can hopefully do just by factoring. I've got x and x. What multiplies to negative 12 and adds to negative 4, I believe, is negative 6 and 2. And if I separate the two parts, x minus 6 either equals 0 or x plus 2 equals 0. So my zeros of my function are 6, negative 2, and of course don't forget your original 4 up there, we found all of the zeros of my function. Plug any of those three numbers into my original function, and it should give us 0. Along those same lines, again, it gives us a way to factor a polynomial. We can just take out that 10. Now remember, I can only divide by a 0 of my function in order to make sure that that's a factor. So when is x minus 10 equal to 0? Well, of course, when x equals 10. So let's put 10 in the box. Say 2, negative 14, negative 56, negative 40. And let's do that synthetic division. Drop the 2, makes 20. Add them up is 60, makes 4. And multiply is 40, add them up is 0. So I've got 2x squared plus 6x plus 4. Now you might notice that all of those have a 2 in them, so I could factor that by first just taking out a 2 and hopefully making that easier. And then I can factor again by saying 2 times x plus 2 and x plus 1, multiplying to 2 and 2 plus 1 being 3 in the middle, and we've got that. Now remember, if I'm factoring the polynomial, that is only what I got from my division. So don't forget to also include x minus 10. But you now have the factored form of the original function f of x, written in standard form up top, but written in factored form, all of its parts separated out down here at the bottom. I hope that helps you factor and find zeros of polynomials. If you have any questions, see your teacher. Good luck and have fun.